Okay, so coming on back to our um, our lesson from before. Now, I just noticed that there is a sprint, but I have not taught you how to form an improper fraction yet. This is brand new. So, step one, improper fraction. You're going to multiply the denominator by the whole number. So, 2 times 1 is 2. So that is step one. Multiply the denominator by the whole number. 2 times 1 is 2. Step 2, add the numerator to your new number. So 2 times 1 is 2. 2 plus 1 is 3. And step 3, keep the same denominator. So let's try this over here. So step 1 is to multiply. 5 times 1 is 5. Plus 1 is 6. Keep the same denominator. 5 times 2 is 10. Add the numerator is 11. Keep the same denominator. 5 times 3 is 15. Plus 1 is 16. Keep the same denominator. You're going to always carry that denominator over. It doesn't matter what it is, you're going to carry it over. 5 times 4 is 20. 20 plus 1 is 21. Keep the 4. 4 times 1 is 4. 4 plus 1 is 5. Keep the same denominator. 4 times 1 is 4. 4 plus 3 is 7. So it's times plus, times add, multiply, add. Okay, so keep the same denominator. 5 times 1 is 5, plus 2 is 7. Keep the same denominator. 5 times 1 is 5, plus 3 is 8. All right, so I'm going to challenge you right now to see if you can do the next two on your own and come on back and see how you do. Okay, so how did you do? Did you do bring over that denominator? 5 times 1 is 5, plus 4 is 9. 5 times 2 is 10, plus 4 is 14. Bring over that 5. 5 times 3 is 15, plus 4 is 19. Bring over that denominator. 4 times 2 is 8, plus 1 is 9. Bring over that denominator. 4 times 2 is 8, plus 3 is 11. Bring over that denominator. 4 times 3 is 12, plus 1 is 13. So when we start adding and subtracting fractions, sometimes it's easier to turn it into an improper fraction in order to actually add or subtract in order to find your answer a little more simply. So that's why we do it. Bring over your denominator. 4 times 3 is 12. 12 plus 3 is 15. Bring over your denominator. 3 times 4 is 12. 12 plus 1 is 13. Bring over your denominator. 3 times 4 is 12. Plus 2 is 14. Bring over your denominator. 5 times 2 is 10. Plus 3 is 13. Bring over your denominator. 5 times 3 is 15. Plus 3, 18. Bring over that denominator. 5 times 4 is 20. Plus 3 is 23. Bring over that denominator. 6 times 2 is 12. Plus 1 is 13. Bring over that denominator. 8 times 3 is 24. Plus 1 is 25. All right. So I'm going to have you finish 23 through 44 independently, and then I want you to come back and check your work. Let's try it and see how you do. All right. So hopefully you finished up. 27 over 10, 49 over 10, 9 over 8, 11 over 6, 29 over 6, 37 over 8, 13 over 8, 19 over 8, 33 over 10, 47 over 10, 24 over 5, 33 over 8, 35 over 8, 39 over 8, 17 over 12, 19 over 12, 25 over 12, 37 over 12, 31 over 12, 41 over 12, 47 over 12, 55 over 12. Okay. So if something's wrong, if you got a number wrong, go back and make sure that you multiplied first, then added. You multiply up, add up. Multiply first, add second. All right. So now let's try it again on this side. All right. So bring it over. 2 times 2 is 4, plus 1 is 5. Bring it over. 2 times 3 is 6, plus 1 is 7. Bring it over. 2 times 4 is 8, plus 1 is 9. Bring it over. 3 times 1 is 3, plus 1 is 4. Bring it over. 3 times 1 is 3, plus 2 is 5. Bring it over. 10 times 1 is 10, plus 3 is 13. Bring it over. 10 times 1 is 10, plus 7 is 17. So hopefully you're getting the swing of this now. After we've done 44, 45, 46, 47, 48, 49, 50, 51, 52 problems. Okay, let's keep going. Bring it over. 10 times 1 is 10, plus 9 is 19. Bring it over. 10 times 2 is 20, plus 9 is 29. Bring it over. 10 times 3 is 30, plus 9 is 39. Bring it over. 3 times 2 is 6, plus 1 is 7. Bring it over. 3 times 2 is 6, plus 2 is 8. Bring it over. 3 times 3 is 9, plus 1 is 10. Bring it over. 3 times 3 is 9, 10, 11. Bring it over. 4 times 4 is 16, plus 1 is 17. Bring that 4 over. 4 times 4 is 16, 17, 18, 19. Bring it over. 5 times 2 is 10, plus 2 is 12. Bring it over. 5 times 3 is 15, plus 2 is 17. Bring it over. 5 times 4 is 20, plus 2 is 12. Bring it over. 6. 6 times 3 is 18, plus 1 is 19. Bring it over. If this is moving too fast for you, stop it, practice, check your work. Stop it, practice, check your work. 8 times 2 is 16, plus 1 is 17. All right, the next side is all about you right now. All right, you just watch me do 22 problems. And hopefully you're doing it along with me. So your job now is to complete the rest of this sprint as quickly and as efficiently as you can and come back and check your work. All right, let's do it. Go. All right. So let's go over it. 23 tenths, 31 over 10, 7 over 6, 11 over 8, 23 over 6, 29 over 8, 21 over 8, 15 over 8, 43 over 10, 37 over 10, 17 over 6, 23 over 8, 31 over 8, 25 over 6, 13 over 12, 23 over 12, 49 over 12, 29 over 12, 35 over 12, 43 over 12, 53 over 12, and 59 over 12. So if there's something wrong, go back and check your work. Make sure you multiply first and then add. So your multiply up, add, multiply, then add. So if here is your whole number, and here's your fraction. You multiply up, add 2 there, right? You drag that across, and you have a brand new number on top. All right. So let's go back to our concept development. And we are now working with numbers between 1 and 2. All right, so here we go. We have 1 whole plus a third, and you're going to take away a half. You're going to subtract a half from that. So, of course, we do not have like units, so we have to do something in order to create like units. So what are we going to do to create like units? You're right. We are going to find a common denominator. So let's do it. We have 3 and 2. 2, so hopefully you're getting the hang. 3 times 1, 3 times 2. Oh, wait, look. What's our common denominator? 6, right? So we're going to keep 1 as is. Now we're going to multiply 3, 1/3. We're going to multiply it by 2. Multiply by 2. Our 1/2, we're going to multiply by not. Oh, shoot. I did 6 instead of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. That's what I did wrong. Like something's not working out here. Wrote down the wrong numbers. Okay. 2 times 3, 2 times 3. So now I have 1 and 2, 6. Subtract 3, 6. Now wait a minute. If I were to stack these problems, 1 and 2, 6, over 3, 6, we kind of have a problem. You can't take 3 away from 2. You can't do that. So what I have to do is, if you remember what we were doing before, remember when we were subtracting in that sprint, and I told you that I was turning the whole number into a fraction. So really, 1 is really 6 over 6, right? So what you do, 6 over 6 is still equal to 1. And why did I choose 6 over 6? I chose 6 over 6 because we're working with this denominator and we can't add or subtract unless we have like units, right? So 6 plus 2 is 8. 6 now, subtract 3, 6. Now I can subtract and get 5, 6. Okay, so this is very algebraic. I'm going to show this to you in another way, so that you can get a handle on what we're doing here. Okay. We have 2 different methods, and I'm going to show you a couple different ways. Okay, so I'm going to show you using that rectangular fraction model of what exactly I just did right here. So I'm going to go down here where I have more room. So we had 1 whole, right? Here is 1 whole. And that's coming from right here. Plus, we had 1/3. So we had 1 and 1/3 from above, right? Oh, geez. All right. So we have 1 and 1/3. And we're trying to subtract a half from it. So what we did over here to this 1 and 1/3, we multiplied by 2 because we created a a common denominator, right? So I have to create 6 equal pieces here. Oh, look, I just did that. I took the whole and I created 6 equal pieces right here. Then I multiplied by 2. Now I have 6 pieces here. So I have 6 over 6. I have 6 of 6 pieces. Plus I have 2 of the 6 pieces, right? So that equals 8/6. Now over here, I multiplied by 3. And now instead of having 1/2, I now have 3/6. So I have 1/8 minus 3/6, which is 5/6. And that is a way that is for you to connect with based on what we've been doing. Is this is very algebraic. I just know that this is 6 over 6 because I know I'm working with this denominator. So 6 over 6 plus 2 over 6 is 8 over 6. And then I have 3 over 6. So if I do that down here in our rectangular fraction model, I have one whole. And remember my one whole, I turned it into 6 over 6. So there's 6 pieces of 6 pieces. Plus 2/6. So 6 over 6 plus 2/6 equals 8 over 6. Now I take my 8 over 6 and I subtract it from 3 over 6 and I get 5 over 6. 5 over 6 matches this 5 over 6. All right, let's try another. Problem 2. All right, notice there's a lot of room here. Notice I took up a lot of room here. Okay, 1 1/5. So here is 1 whole plus 1/5. And then I have 1/3. And I'm going to take 1/3 from 1 1/5. So what do we have to do first? Are these like units? No. This is 5 and this is 3. So we have to scoreboard. If you haven't figured it out yet, you can scoreboard. Hopefully you're starting to catch on. Three, 9, wait, 3, 6, sorry, 3, 6, 9, 12, 15. All right. So now I need to multiply. I'm going to keep my one whole and I'm going to take 1/5 and I'm going to multiply by 3. So I'm getting that from here. And I'm going to subtract 1/3. But 3, I need to multiply by 5. And I end up with, my new problem is 1 3/15 subtract 5/15. I have a problem. If you normally you stack a subtraction problem and addition problems, you stack them to solve. Now, wait a minute. I can't take 5 from 3. So what do? I come over here and I'm going to change this 1 into a fraction. What fraction do you think I should change that 1 into? You're right. I should change it to 15 over 15. 15 over 15 plus 3 over 15. And I'm just going to bring over 5/15 just so I don't lose you. Now, 15 plus 3 is equal to 18. 15. I'm going to drag him over again. Now I can finally subtract. 18 minus 5 is 13/15. Now, let's go ahead and use the rectangular fraction model. So I have one whole and I change it into 15/15. So let's go 1, 2, 3, 4. So I have 5. And let's cut this in thirds. Now I have 15/15, right? 15/15 are colored in. Now I had to multiply this by 3. So let's multiply this by 3. Oh, look at that. Now I have 3/15, right? That's what I just did. And what did I do to my 1/3? I multiplied it by 5. 1, 2, 3, 4. 1, 2, 3. Okay, so you can see how our boxes, our rectangular fractional models match what we did here. So we split this up. We have 15. We have 15 out of 15. We have 3/15. And now we took away, 1 and 3/15 is 18/15. And we subtracted 5/15 from it and got 13/15. So now 1, 2, 3, 4, 5. We need to take this 5 out of 15 away from here. 1, 2, 3, 4, 5. And we should have 13/15 left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our representation matches our algorithm. All right, let's go to the next problem. So our big idea here is you have to be able to see that this whole number can be broken up into a whole fraction that's either 5/5, 6/6, 7/7, 8/8, 9/9. And that depends on what your common denominator is. It's going to match in order to add these numbers up. So remember, it always has to match. So first, step 1, what are you going to do? Yes, you are going to scoreboard, or if you already know what it's going to be, you don't have to. If you're starting to see the repetition, see the pattern, remember, that's what we're always looking for, are patterns, right? All right, 2 times 1, 2 times 2, 2 times 3, 3 times 1, 3 times 2, 3 times 3. Oh, what? Hopefully you saw that. All right, so now what we're going to do is we're going to keep our 1 the same. First, let's just change out our fractions. 1/2, and we're going to multiply that by 2 times 3 is 6, right? And then we're going to have 2/3, and we're going to multiply that 3 times 2, right? And our new number is 1 and 3, 6, subtract 4, 6. Now, you can't take 4 away from 3, right? And so the next step is what I like to do is I'm going to now change my whole number. And what am I going to change my whole number into? Remember, it has to match your common denominators here. So because it's a whole number, it has to be the same number on the top and on the bottom. So I'm going to change it to 6/6 plus 3/6 minus 4/6. 6 plus 3 is 9. 9/6. Now, because we're mathematicians and we like to stack our problems in order to subtract, I'm going to rewrite it like this. Okay, now I could subtract. Before, I could not subtract this. So I had to change it so that I could subtract it. So 9, 6 is going, you're going to take 4, 6 away from 9, 6, which is 5, 6 is your answer. Okay, this is just the mathematical algorithm. This is what you're going to follow. What we do here in our class is we like to show what we just did. So I'm going to take my whole and I broke it up into 6, right? So I have 6 of 6, correct? Now I have to take my half and I'm going to divide it into 3 because remember we multiply by 3. And now we have 3 6, correct? So now what we do is we come down and put it together. And we go 6 over 6 plus 3 over 6 equals 9, 6. Now, what did we do to our 2/3? Oh, we multiplied it by 2. And now we have 1, 2, 3, 4, right? We have 4, 6. Subtract 4, 6. Make 9. Oh, 6. Excuse me. I do that. 4, 6. And you get 5, 6. All right. So hopefully you're seeing how these two go together. And this is just the diagram of what exactly we're doing. We're taking a whole and we're breaking it up into 6. Because if we do that, then we can actually add these numbers up so we have a number we can subtract. Otherwise, you cannot subtract. You're stuck. You can't do one thing. All right, let's go to problem 4. All right, problem 4. We have 1 whole, 3 fourths. Here's 1 whole, 3 fourths, and you're going to subtract 5 fourths from it. Well, do we have common units? No, we don't have a common unit. So step 1, find that common denominator, right? 1, 2, 3, 4, 5. Because I know where to stop. That's why I stopped there. 4, 8, 12, 16, 20. 5, 10, 15, 20. All right. Now we're just going to bring down the whole number. And we are going to multiply 4 times 5 is 20, right? And now we're going to subtract. Here's 4 fifths. And the reason we're having to do all this work is because currently in this situation, we cannot do anything to our problem until we convert it into a problem that's doable. 5 times 4 is 20, because right now it's not doable. Now we're changing it into something doable. So now I'm going to continue to bring down my whole number, and I end up with 15 20ths, and I'm going to subtract 16 20ths. Okay, I still can't do this problem. And I can't do this problem until I change my whole number. What am I going to change my whole number into? You're right, 20 over 20 plus 15 over 20. 20 plus 15 is 35 over 20 minus 16 over 20. Now remember, because we're mathematicians, we're going to stack our subtraction problem. 5 take away 6. Well, no, we're going to have to borrow. 15 take away 6 is 9. 19 20ths is our answer. All right, now let's go over here and see if we can make this, figure out what we just did with this. So we have 1 whole. We changed our whole into 20ths. All right, so let's change it into 20s. 1, 2, 3, 4. So I have 1, 2, 3, 4, 5. And I'm going to break it into 4 this way. Now I have 20. I converted this one whole into 20 20ths, correct? Now, what did I do to my fraction? I multiplied it by 5. So 1, 2, 3, 4. Now I have, because I had 3/4, right? So you could see it better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 15 20ths. They match. Now let's see if we have 35 altogether. So here's 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Yes, I have 35 20ths. What did we do to our 4/5? We multiplied it by 4, right? 1, 2, 3. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, we have 16 20ths, right? And because we're mathematicians, we stack our subtraction, our addition and subtraction. They match. Perfect. All right, last problem. All right, what I want you to do is I want you to try it on your own. And then I want you to come back to see how you do. All right, let's check our work. All right, so can I add these straight across right now or subtract these straight across right now? No, I don't have like units. So I have to change it. I have to scoreboard. If you know that that's 18, you wouldn't have had to do it so far, but hopefully you're starting to see a pattern. I'm going to carry down my 1. I'm going to do 4/9 times 2 over 2. Subtract 1/2 times 9 over 9. I have 1 and 18, 8 over 18. Subtract 9 over 18. Now I'm going to convert my 1 into 18 over 18 because that is the common denominator that I'm working with. And in order to add, the common denominators have to match. So whatever is on the bottom is on the top because it's a whole number. So 18 plus 8 is 26 minus 9/18. 9/18, and it's 17/18. Then I come over here to check. Did I turn this into 18 over 18? I multiplied this by 2, and I ended up with 26/18. And I came over here and divided this or multiplied this by 9. So I ended up with 9/18. Subtracted 26 from 18. And 26/18. I subtracted 9/18 from 26/18 and got 17/18. All right. Hopefully this makes sense and you're ready to take on our problem set. Okay. So problem set. For the following problems, draw a picture using the rectangular fraction model and write the answer. Simplify your answer. So I would scoreboard. I would do exactly what we did. You can draw a tiny little rectangular fraction model. Why don't you just do it for 3, like A, D, E, or you choose. Why don't you just do the fraction models? If you've got the hang of it and you don't necessarily need to do it, just go ahead and do the rectangular fraction models for 3 of them. And if you still need the rectangular fraction models, go ahead and continue to use them. All right, so this shouldn't be any more difficult than what we just did together. Here is our problem set, word problems. Jean-Luc jogged around the lake in 1 1/4 hours. William jogged the same distance in 5/6 of that hour. How much longer did Jean-Luc take than William in hours? So take than, right? How much longer did Jean-Luc take than? So you know that's a subtraction problem. Is it true that 1 2/5 subtract 3/4 is equal to 1/4 plus 2/5? No. Prove it. Show me. Show me the steps. Step 1, I'm going to score words. Step 2, I'm going to change my denominators to make like units. So I want you to prove that to me and show me why that is true or untrue. You decide. Go through and show me the truth. All right. I'm sure you will do very well. Good luck.